Hey everyone, this is me again, and this is part 2 of my Angular dependency injection video series. If you haven't watched the first one, it's very important that you do, because this part is based on the first part. You can find the link to the previous video in the video description down here. So please make sure that you watched it, and hopefully I will be able to teach you a lot of new stuff today, or at least make some things a little bit more clearer. This part, I'm going to focus on the R3 injector and providers. So on the first video, we started by learning that Angular actually used two different injectors. One of them is an injector that is created for each component or directive, which we called the node injector, because he's associated with a specific node. And there is another injector, it's called the R3 injector, which lives on the module level. Basically, this is the injector that kicks in after Angular can't resolve and provide you a dependency because it can't find it on the node injector hierarchy. If you actually want to see those injectors, like actually see the code, you can do something really nice. You can visit your app module and your app component. Now, if on the app module, you're going to use the instructor and ask for the injector, get a reference to the injector, and then, just log I'm the app module, and this is the injector, and then do the exact same thing on the component level. Let's just change here the string by saying app component. If we visit the browser now, you will see two completely different injectors depending depending on which context you ask for this injector. If I ask to a reference to the Angular injector in the module level, I'm going to get the R3 injector. If I'm going to ask for the injector at the app component level, I'm going to get the node injector of the app component. So this is just another way to explore the fact that Angular actually use two different injectors. So this part, I'm going to focus on the R3, the module level injector. Because as a reminder, when you ask for a dependency on a specific component, if I jump to the project again, and let's jump right in and let me go straight to my app component. And my app component, I revisit the template, and there's a router outlet here because we can inject the eager module, who's got its own eager feature component, who's got a child component. I'm going down the tree to the very last child component, and here on the constructor, I'm gonna ask for the counter service, which we created on the previous video. And actually, let me just split the screen and open the counter service here, so we get like a reminder of how it looks like. No decorators, no definition, no nothing. Now, going back to my app, there's no error, but if I try to load the module, you'll see R3 injector error. Now, as a reminder, if I provide the counter service, if I configure the node injector of the child component with the counter service, provide theirs. Right? So first of all, there won't be any error because the child component asks for the counter service. It can find it on the node injector. What happened before is the child component asked for the dependency. It couldn't find it. So it looked at the eager component node injector. We're talking about the hierarchy of components. There is no hierarchy between Angular modules. They're being flattened. There's nothing like an app. The eager module is a child of app module, not at all. So the child component looked for the counter service on his injector, a node injector, couldn't find it. Looked at the parent the eager component node injector, he couldn't find it. You look at the app component node injector and he couldn't find it. And then he looked for it on the app module. Now the app module at this point contains all the providers that was configured for the app module itself and each module that it imports, not lazy loaded, eagerly import. But then again, Angular DI couldn't find it. So he stepped up another level after the app module, look at it on the platform module, the module that Angular creates, couldn't find it, hit the null injector, and we got the R3 injector error, couldn't find the dependency. So if I take this away again, hopefully after my explanation, you understand why you're seeing an R3 injector error, all right? If you dig a little bit more like downstairs, you might see, here you go, get node injectable. So Angular tried first to, to look for this dependency on the node level, but eventually he hit the null injector and got the null injector error. Cool. So how do we configure our service, which currently doesn't have any kind of configuration at the R3 on the R3 injector level? We've got few options. Let's explore them. First of all, and the most recommended way, you know what? Let me rephrase it. Let's first look at the classic way or the well-known way to provide a service and to configure our service at the module level. Let me hit the app module and just create an array of providers here, register my counter service, and now my counter service is provided, or to be more precise, I configured the app module injector, which is the R3 injector, with my counter service. So first of all, I shouldn't get any errors whatsoever because right now Angular can find a dependency. I ask for the child component. In the child component, I ask for the counter service. Again, Angular look at the entire hierarchy, hits the app module, and you could find it, and that's it basically. Those days, with the latest versions of Angular, this way considered to be less preferred. Let me explain. Let's say that you configured the R3 injector at your app module. I mean, technically you created a dependency right here, which means that this code gonna be obviously bundled together with your code. But what if this is a module where the usage of counter service is optional? So when someone uses this app or uses this model, he might hit the code that actually needs the counter service, but it might not. When we define the counter service at the app module this way, it is not tree shakeable, which means that by analyzing the code, our Angular can't know if the service is actually needed to be bundled at the app level, because it's written implicitly, right? It's explicit right here. The preferred way to configure the R3 injector is by using the injectable decorator with provided in. Now let's talk about this provided in for a second. The app module is our root module, which means that if I declare here, hey, take this counter service and provide it on the root level, that's technically the same like including the counter service at the app module providers array, with one very important difference. the app module now doesn't need to know about the counter service whatsoever. So within the same file, within the same decorator where I declared my counter service, I've also configured the R3 injector, telling AngularDI, hey, I want to provide this counter service at the root level. So now the code obviously should work. And if we go back to the slide, this visual is kind of explaining what's going on. Now you might wonder, wait a second, there is only one root. What if I've got several modules in my app? Well, it doesn't really matter because, like I mentioned before, there is no hierarchy between modules, between eagerly loaded modules. When I say eagerly, I mean modules that is known at build time. Like look at the app component. He's explicitly import eager feature module. So there's no real hierarchy. Everything considered to be the root, which means that Angular takes a go through the providers array if declared of each and every module and just flatten this array. So by providing a service at the root level, we technically create a singleton at the app module, at the app let me rephrase it, in the Angular module level, which means that all the components that are a child of, well, app module that depends on other modules, but it doesn't really matter, will be able to locate this dependency because he was configured on the R3 injector, which lives on the app module. The R3 injector that lives on the app module because I provided it in root. So what are the other options? There is this any keyword. I mean, I can say, hey, take this counter service and please provide it at any module. Now let's revisit one of the modules, like the eager module right now. And on the eager module, I'm going to use my constructor and I'm going to ask for the counter service. And I'm going to do the same thing on my app module. Here's my app module. And here also, or I've already got it, I'm going to ask for the, no, sorry, that's the injector. I'm going to ask for the counter service as well. So I've got two modules in my app. Come on, copy this, please. Put it here. Thank you. So now I've got two modules in my app. Both of them ask for the counter service. And I configure the R3 with the any keyword, which kind of literally means please provide this counter service at any module. How many instances do you think I'm gonna see? How many instances of counter service how many instances we're gonna see? Basically, I don't have any other words for this. So if you're surprised to see only one and you kind of like confused because I just used the keyword any, so I don't know, I've kind of expected maybe because I ask for the service at this module and this module, and I explicitly defined any provided any module, so you might expect to see like two different instances. But the thing is that the any keyword have no meaning if the module is an eager module. This module is not lazy loaded because, like I said before, there is no hierarchy. App module, import eager module, and you can think about the process as merge. You end up with one root module. It doesn't really matter. So by saying any, there's no meaning. Where app any is important? When you've got a lazy loaded module, and we've got one. because when you lazy load one of your modules at runtime, that's the only scenario where Angular actually create another root level module injector. You can think about it like this, which means that if I go to my lazy loaded module, and here I'm gonna use the constructor and ask for the counter service, and then load the lazy module, I'm gonna have two different instances because I configured a provider with any, which got no meaning if my modules are eager. But if I load a lazy module and this lazy module asks for the counter service dependency, and this class, the counter service, is provided at any module, I'm gonna get another instance. And if you want to get rid of this instance, just saying don't provide it any, provide it in root. So even if you load a lazy module, you're still gonna get one instance. So you've got some kind of control. I do think that this keyword is a little bit confusing, the any, because maybe provided in lazy was more like a better name to use. I don't know, but every time you're thinking about any, I want you to think about not provided it in any module, provided in any lazy module, which means that if you're gonna load lazy module, you're gonna get a new instance. And that's the only point at any, because otherwise, provided at root. So let's do a quick let's summarize root and any. When you configure the injector using the provided in that lives within the injectable decorator, which is the preferred way because there is no hard dependency between my modules and this actual file. When we when we use the root keyword, it means that this service is gonna be configured at the Angular module level. In other words, we're gonna create a singleton that is shared between our all app. Everything that lives under the app module, which technically is everything. Now, if I'm gonna provide it at any, I won't see any different unless I'm asking for this dependency in a lazy loaded module. And that's the only scenario when a new root level injector is created, where I've got like a new root module. So hopefully it was a clear explanation and you get like a better understanding of what's going on. But let me take it even a step further. So what is a platform? All right, I get the root, I get the any. We're gonna speak about the module in a second. I get the any lazy module. Root is like everything else. And so what is platform? Now, there are some scenarios where you've got more than one Angular app on the same page. Let me define what is an Angular app and what does it mean more than one Angular app. Angular app, you can think about it as like an Angular module that's being bootstrapped, which means that on any Angular app, you've got only one module, like this app module, which is used to bootstrap your app. So you get a context and you've got like the entire life cycle and you technically got an Angular app. Now you can, if you want, to bootstrap more than one module. If you look at this code, which I refactored a little bit, you see that I'm using the platform browser dynamics. So I get a platform reference, and then on the same platform, I'm bootstrapping two modules, the app modules and the app2 modules. And on my index.html, I'm going to see two app root. So basically now I created a situation where I've got more than one root module. I've got two root modules. And what if I want to create a singleton that it's shared between those two app modules, two root modules to be more precise? Well, in this scenario, I need to step up. Who is the parent of the root modules? 1 root modules or 10 root modules? Where it's the platform module. And the platform module is created by Angular. But we can't configure its injector using the provided in. So if I go back to my counter service, I can create a singleton that lives at the platform level. Let me do it for a second. Which means that now, let's say that I've got my app module. Here it is. You know what? Let's put this code inside the app component that live inside the app module. And the reason I'm putting it here because I want to introduce some template so we can actually play with this counter. So here I've got some template, and this is like the counter service, not private, public. So if I go back to my app, this is my first root level component, and here I've got the counter and all good. Now I'll go to the other root module, app2 module, which got one bootstrap component in this use case, which is the app2 component. I'm gonna inject the counter service, and I'm gonna create a template here, and again just make it public. And now let's see what's gonna happen. So on the left side, this is the first step. I'm gonna increase the counter. Let me make it a little bit larger. I'm gonna increase the counter to 20. Now I'm gonna start to increase the counter on the other module, and you can see it started at 22. And I can step it up to 41. And then if I go back to the other root modules, it started at the same number where the other root stopped. Now, if you expected to see some kind of change detection sync between the two root modules, that's not gonna happen because each Angular app, each root module, which represent an entire application, got its own life cycle. So it's not like a real-time mechanism, and that's not the point. I mean, you're not providing something at the platform level because you want to create some real-time experience. If you do want to do it, there are ways to do it, which pretty easy, and I'm gonna show some example in future videos. But if you've got some business logic and you've got more than one root on your page, and you want to share this single instance between two different roots, you configured your code, you provided, you configured the R3 injector at the platform level. If I go back to the slides, you configure it right here because the platform module is the parent of one or more root modules. Now, let me be honest here. Most of the time, most of the common use cases when you've got some logic, and you decided that this logic should be a singleton, this object should be a singleton, and this logic should be shared across your app. So there is no point of like providing it on the injector, on the node injector level. So in most typical apps, most of our services will be registered at the root level, because singletons are our friends, and we've got like a bunch of use cases to create those instances only once at the root level, so everyone will enjoy it. But hopefully after this explanation, you understand the other options. And in future videos, I'm gonna start providing some real-world example they take this, API, which currently I just demonstrate, and implement it in a real-world scenario. So we covered the platform, we covered the root, we covered the any, or in other words, we covered how to configure the R3 injector, because configuring the node injector is putting our service inside of the provider's array at the component level, like we did in the first video. There is another option which I'm just gonna show you, but without an example, because I wanna give you like a real use case, which is maybe I want to provide a counter service on a specific module. For example, my lazy module, which means that this code gonna be registered, and I'm probably gonna get an instance only when it's gonna be available only when lazy feature module is loaded. It's not on the root level. It's not like on any lazy module. This code is being provided in a specific module, and until this specific module is loaded into my system, this service is not visible, is not accessible, and if you ask for a dependency, you're not gonna get it. But again, I'm gonna keep it just theory for now, and I'm gonna show you the actual usage of this in future videos. So that was all about the module level hierarchy, the R3 hierarchy. And the last thing that I wanna teach you in this video is going through the process of injector configuration, because now we've got enough knowledge, I think, in order to wrap this API and to get like a solid foundation for more advanced examples. So let me take a step backward. We introduced the R3 injector and the node level injector, both of them though extending the abstract injector, which means that both the R3 injector and the node injector implement the same method called create. And when Angular wants to create an injector, and it doesn't matter if that's the R3 injector or the specific node injector, Angular, this method expect an array of static providers. And those providers, basically this is the object, let me show you, which I believe that most of us familiar with. If I go back to the app module, and let's say I want to use providers, and I can do this counter service, which is just a shortcut for the most common way to configure this injector. It's a shortcut for saying, please provide me counter service. When someone asks me to provide him the counter service, this is the key, I'm gonna use this class and create an instance out of it. So by doing this, that's actually a shortcut of writing this. All right? So we do know what is a provider. The provider is actually the configuration for the injector. The provider is not our code. It's not that's not the counter service. It's a definition of an object that used to configure the injector. Most of the use cases by providing our code, by registering our code under a key, which means that if we want to use the provider in order to configure the injector, whatever that's the R3 injector or the node injector, we need to provide some kind of a key, which we call the token, an injection token. and instructions, which means in this most common use case that I just showed you, hey di, use this class. Technically, I'm telling Angular, create an instance. I want you to create an instance. I want you to use this class in order to create an instance every time someone asks for the counter service. So that's the key, and this is the instructions. Cool. Now the key can be one of two types, or two types. Let's keep it this way. The most common use case is that the key is the actual class definition or the type. So in this use case, please provide me, use the counter service, the type as a key, and use the actual class to create an instance. You can't use an interface here, so don't even try. It can be either a type that's already exists, or a special key that we create using a function called a constructor that comes from Angular that's called injection token. But I'm going to talk a lot about injection token on the third lesson in this series, and we're going to put it aside for now. So let's just focus on the left side on this slide that you're seeing. The key going to be the type. All right. Now you need to ask yourself this. What do I've got? Which piece of code I'm dealing with? If I've got a class, and every time that I ask for this class or for this type, I'm expecting to get a reference to an instance, which means that I want Angular to create an instance out of this class, I'm going to use the use class. Now the use class is so popular that if you're using the less preferred way of registering your providers, which means including configure the injector or explicitly on the ng module level like this, you can use the longer syntax. But again, because this is so common that you provide a class and expect an instance, you can just do this. And it's so common that if I want to use the preferred way to configure the R3 injector, let me revisit the counter service. I can use the injectable and say provided in root, and I don't even need to pass any extra instructions, because the default is use this type as a key and use this class to create an instance. Cool. What if I've got a function? So when I use the key, I want Angular to run this function and cache the results, and the results of this function is what I expect to get. In this case, I'm using the use factory instruction, which means that I can say, hey, Angular, you see this counter service? First of all, configure the R3 injector, the module level injector. All right, but more than this, use a factory. Remember, the default is use the class. Use the same class, and that's the default. And that's probably gonna work, yeah. All right, just want to show you, so you won't think that that it's not true. But if I want you to run a function instead of it, I can use the use factory. And now I need to provide a function. And now Angular is going to run this function, and whatever this function returns going to be what I'm going to get when I ask for the counter. So for example, if I log the counter right now, what do you think I'm going to get? I've got a function. This function returned the class definition. It's not even an instance, which means that when I use the key counter service, I'm going to get whatever this function return, whatever this factory return. So Here you go. It's just a class definition. It's not even an instance. Now, if this factory, this function, actually return me an instance of counter service, that's going to be pretty much the same as like providing an instance. Here you go. Here is the instance. I've got the increase. I've got the get count on the prototype, and I've got the count observable. So what's the point? Why should I use this factory? The most common use cases is sometime you need to instantiate your object manually because AngularDI can't resolve it. For example, let's say that my constructor needs to get some kind of a boolean. Because you want to decide if you count, sometimes let's not call it a flag. Let's call it use log, which is a boolean. Every time you're doing increase, if someone says like, let's do it private. If this boolean is true, use log, you want to console log, console log discount, for example. So in this use case, Angular won't be able to create an instance. So if I try to tell Angular, hey, use this class and create an instance, I'm gonna get an injector error. Let's try to read it and see what's going on. This constructor is not compatible with Angular dependency injection because the dependency at index 0, I've got just one argument in the constructor, is invalid, which means I can't inject you a boolean. I can't resolve it. In this use case, I can use the use factory and tell Angular, all right, don't worry. When someone asks for the counter service, go ahead and create new counter service. I'm gonna give you whatever the constructor need. For example, I can use my environment production. That's a nice example. So if we are not in production, that's gonna be false, which means that we're not gonna log, and vice versa. So let's see what's gonna happen. First of all, there's no errors. I don't see any logs because I didn't use this. Alright, there's no logs. But if I'm gonna run in production, let's go to the environment file. Oh, I am in production. Let's say production false. So now, right, I can see the console log. So in case that you need to provide the injector a function and you need to make some decisions or construct an object, instantiate an object by yourself, or basically return whatever you want to return, use the use factory instruction. What if you've got an object, any object? It can be a string, it can be a number, it can be an object. And you don't want the injector to do anything with it. When I ask for it, just give it to me as is. In this use case, we use the use value instructions. Let me give you an example. When someone asks for the counter service, let's do something which is not very, like, it doesn't make any sense, but just to demonstrate. Use this value. I am a counter service, which means that now if I go to the app component and I ask for the counter service, I'm gonna get this string, this value as is. Alright, here you go. I am the counter service. AngularDI didn't try to instantiate it, to call new. Angular DI didn't consider this as a function and run this function to get the return, because I told the DI, hey, use value, give me this as is. Now in this particular example, I'm not sure it's making any sense, but if I want to actually provide an instance, I can do the same thing, like new counter, and let me pass through. And yeah, whatever I'm gonna do here, right? It doesn't have to be a function. Whatever I'm gonna do here, Angular DI is not gonna try to invoke it or instantiate it or do anything with it. It's just gonna give me the value. That's it. Just a slight reminder, this second lesson, just like the first, is about going through the API. And if you wonder what are the actual usage of this kind of API, in which scenarios and which kind of features which kind of which kind of features are like more suitable for using factory services or whatever, don't worry, I've got like plenty of examples, and it's gonna be like future lessons which I'm gonna record very soon, like in a matter of hopefully days. Cool. So let's see. I think we covered almost all the instructions. I've got a class. I want Angular to instantiate it. I'm using the use class or just the shorthand. Just mention the name of my service if I'm doing it on the actual app module, the Angular module, or if I'm using the injectable, the preferred way. I'm just gonna say, well, provided in the root level, and that's it. Angular gonna use the key and this class to instantiate. If I've got a function and I want the DI to run a function, I just need to define this function. Run this function, please, and whatever it returns, that's the thing that I want to get when I ask for the counter service. I'm going to show you in future example that we can take it even a step further and define some dependencies here, and actually create a factory that knows how to get some services within Angular and use them, but it was just considered this as a preview. The last one, an object. I've got an object, I've got a string, I've got a boolean, I've got my own way to instantiate a class. I've got a function which I want to run, whatever. I don't want DI to do anything with it. Keep it as is. In this use case, I will use the use value instruction. Now there is a fourth one, which is the use existing, which is a use case where I've got a class. Actually, this slide is very wrong. I've got a, yeah, it's not use value. I should change it. It's existing. And this is, my friend, this is live sliding. I'm gonna change it in a second. So let me explain you the scenario. Let's say that I've got a class that is already instantiated, but I want to use it as provider. But you know what? I'm talking too much. Let me just show you an example. It's gonna be much better than just talking about it. So here I've got a counter service. All good. Let's say, just for the fun of it, that my app component gonna shadow this, gonna provide the same service, gonna configure its own node injector with the same counter service. All right? Which means that now, if the child component that lives somewhere there, I think it's the eager feature component, all right? If I'm gonna ask for the counter, I'm gonna get the counter that was provided on the app root node injector and not the counter that was provided in root. because Angular DI was able to resolve it at the node injector hierarchy. Actually, I can try to trick it. I can try to say, hey, when someone asks you to provide the counter service, use value. I'm gonna give you like a mock object which got a count, which is it wasn't observable or something. No, let's keep it a count. I've got a count here which is 500, and I've got increase. Let me just copy it. Where are you? Increase. That it's not gonna do anything. Let's just alert increase. So now my eager feature component, when I ask for the counter service, actually even the app component, when I ask for the counter service, I'm gonna get it from the node injector. I'm gonna get this, and I'm not gonna get this, the root level in the model. Let's see if I still got everything here. Let's try to do it. Oh yeah, first of all, I should take this boolean away. Cool. So let me try to increase, and I'm getting this alert. You see it? What if, and this is the use case that I actually want to show you. What if app component, for some reason, holds a count? And I want, let me get rid of the code right here. And I want that from this point on, every child node injector, when he asks for the counter service, is gonna get the count from the app component. Let me show you what I mean. This is the child component right here. On the child component, this is the eager feature component. I'm asking for the counter, and I'm gonna log the counter count. All right. Now, if I remove this, now I'm gonna get 500 because I kind of provided it on the app component node injector. So I'm probably gonna get 500, as you can see here. If I'm gonna remove it from here, the injector couldn't find it on the node injector level, so I'm gonna find it on the root level. So I'm gonna get 0. Here it is. But what if I wanna do something even more interesting? I wanna say, all right, when you ask for the counter service from this point downstairs, I wanna use class. I wanna use the app component, because the app component got a count. So if you are a child of app component, you don't need to change anything. All right, you're looking for the counter, but you actually get the count from the app component. So now I'm expecting to see 5,000, which is nice, but we have a problem. If I'm gonna create a constructor here, and let's say app component instance. All right. I use this percentage to be able to do color green. All right. You're gonna see that I'm getting 2 instances of the app component. Why? Well, the first instance is because Angular instantiated our component in order to render something for the screen. The second instance is because we're using the same class and we told Angular DI, hey, use this class and instantiate it and save the instance, so whoever gonna ask for the counter service gonna get this instance. Now, if we've got this kind of a scenario, which is more common that you could think of, and I will show you some examples. I've got something for the future, the near future lessons. But if we got a scenario where we want to use a class that is already existing, it's already being instantiated, and we want to prevent this double instance, we can tell the provider, hey, when someone asks for the counter service, use the existing app component because it's got a count and so now I'm going to get only one instance of app component, and the child component down here gonna get the count from app component. Look at this for a second and try to imagine a scenario where somewhere down the tree you want to kind of shadow the root level service with a value that actually coming from a component, because the component knows about a specific value which is important for the children. A very interesting technique, but currently we focus on the API. So this is the use existing. If I go back to the slides, now I can say use existing here. And like I promised you before, this is gonna be live sliding. You got a class which is already instantiated. You want to keep it as is, don't do anything, alright? Just give me a reference. What you want, a reference. Reference. And actually I even want smaller font. So use existing. And this is enough for today. Let me go back quickly and just summarize. So we talked about the R3 injector, which is the injector that kicks in after Angular couldn't find the instance or like the code that you are asking for on the node injector hierarchy, on the components level. So it hits the module, and every Angular app got at least one module. And technically, it hits the R3 injector and start looking what's going on there. Now, if you want to configure the R3 injector, the preferred way is to use the injectable provided in property and configure the R3 by saying, all right, I want the root module, which is like all the modules, a singleton at my app level, because everything is wrapped with the app module. Or I want to create a new instance for any lazy loaded module, not any module, any lazy loaded module. Or I've got more than one root in my app, so I want to get a singleton which is at the platform module level, which means that all of my root levels modules are gonna get the same instance. So it can be a platform. Platform, right? Or an example that I haven't shown you, just told you about it. I can even say I want this service to be registered on a specific module only when this module is available, like my lazy feature module. The second part of this talk was about the provider. How do I use the key and provide different instructions in order to tell the AI what I want to get when I use the token, when I ask for this dependency. Cool. On the next lesson, I'm going to talk about injection tokens. I'm going to talk about how we can write code that depend on abstraction and how we can leverage dependency injection with services and abstract classes and implement some very interesting patterns. So I hope you enjoyed it. I hope you learned something new, or you got like a more clearer explanation of something that you might already know. This way or another, I'll be more than happy to get some comments if you like it or not, or if you got some ideas of how to present this kind of stuff in a better way, or if you've got any questions. If you do have questions, please leave a comment. I will try to answer each and every comment I see, or go to near.life where you can find my email, my Twitter account, my LinkedIn, whatever. I mean, any way to contact me. So this is this is it for today, and see you on the next one. Thanks.